Chapter 6, Lesson 5 of Advanced Algebra, and we've been looking at irrational root theorem and the imaginary root theorem, and we remember that these come in pairs. So one of the things that we'll want to be able to do then is to take these roots and to write the polynomial in standard form. Now this is something that we've done before, so it's nothing different. It's just we have to recognize what the zeros are in order to write the factors, and then again we use the factors to multiply together to get in standard form. So as a review, let me just cover one easy one, or do an easy one for us, what we would consider to be easy. Remember, if I told you that the zeros of a polynomial are 2 and -7, and I said write the polynomial in standard form that has these as its zero. Remember, what we would do is we would take these zeros and we would put them in their linear factored form. And remember, factored form is we do x minus, and then here we put the zero, whatever it is. So I would take x minus, and I put the zero in, 2, and then I do x minus, and I put the 0 in. -7 is going to make this positive. Now I have the factors. So I go from the zeros to the factors, and now I multiply those together. So I use the distributive property, x times x plus 7, and then the -2 times x plus 7. So that's x squared plus 7x minus 2x minus 14, and then I add my like terms, so this would be x squared plus 5x minus 14. This would be the polynomial in standard form if these were the zeros that were given to me. Now, when we're talking about using imaginary zeros and complex zeros and we want to put it in standard form, it's no different. We're still going to use the form x minus, and then in this place goes the 0, whatever it is. The only thing we have to remember is that the imaginaries come in pairs and the irrationals come in pairs. All right? And so we'll put those all in and then we'll multiply them together. So I'll do one example in this video, and then I'll do another video where we'll do a number of examples so you can watch as many as you need. But we'll just do one right here. So let's say that I told you that the number 3i was a 0. Write the polynomial in standard form that has 3i as its 0. All right, so I know that the 0 is 3i. Now what I have to remember is that there's another 0 that they didn't tell me, because they expect me to know that if 3i is a 0, what else is also a 0? Well, it's conjugate, so -3i is also a 0. So that's the toughest part about this lesson. Now I have to just simply put them in factored form. So it's x minus, and then I put the 0 in, 3i. And then it's x minus, and then I put the 0 in. -3i is going to turn that into positive 3i. Okay? And now I simply apply the distributive property. So I take this x times x plus 3i, and I take -3i, and I multiply it times x plus 3i. Now, we just have to be careful of watching all of the imaginary numbers. Now, let me make one very important note here. When you multiply a number by its conjugate, you should remember that it always comes out to be a real number. So if I do this right, my polynomial that I end up with should never, ever, ever have an I in it anywhere. And it also, when we're doing irrational roots, should never end up with a square root in it anywhere. Because I'm multiplying by the conjugate, those i's are going to go away, or those irrational numbers, those square roots, are also going to go away. So just keep that in mind. If you end up with an I or a square root somewhere in your polynomial at the very end, you've done something wrong. All right? So let's keep that in mind as we move forward. So x times x is x squared, and then x times 3i is simply 3ix. Or 3xi, it doesn't matter. That's multiplication and it's commutative. So now I have -3 times x, or -3i times x, so that's a -3ix. And you'll notice these are opposites, so that I is going to go away. And then -3 times 3i. Now here's where you have to be careful. You multiply the number times the number, so you have -3 times 3, which is -9, but then you have I times I squared, or I, excuse me, which is I squared. But what is I squared? We know I squared is what? negative 1. And so this is negative 9 times negative 1, which actually changes the sign of that 9 into a positive. So again, you'll notice though that the I is gone. So then these add up to 0, which leaves me then just x squared plus 9. This is the polynomial in standard form that has 3i as a 0. So a few things I have to remember when I'm working with imaginaries, but it also applies to those irrationals. These imaginaries always come in pairs, so I'm expected to know that I need to use the conjugate. We then put it in its factored form by using, again, x minus, and then right here we put the 0, whatever it is, right? And then we simply apply the distributive property. And then remember at the end, my polynomial at the end here should never, ever, 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 ever have an I in it, and should never, ever, 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 ever have a square root in it, because if I've done the arithmetic correctly, the I or the square root, or both, will go away. All right, so keep that in mind. All right, so that's all we'll do for this video. Again, in the next video, I'll do a number of examples. I'll do, some that are more easy than others, and some that are more difficult than others. So you can watch what you need to watch to help you out moving forward.